Welcome to our product setup instructions. In this video, we will show you how to use the TFLN-NULL bias controller. Firstly, you need to check the bias voltage input range of TFLN modulator. Because when controller's bias voltage output exceeds the maximum bias voltage input of the modulator, it will cause irreversible damage to the modulator. Secondly, you need to choose the power input channel using a jumper. For example, connect IN1 and COM together with a jumper. And then you can use a power adapter as the power supply. If you connect IN2 and COM together with a jumper, you can use a 5 volts DC power source as the power supply. Thirdly, you need to measure the actual heater resistance of the modulator by using a multimeter. Then send this value to the controller via GUI. Here we will show how to use the GUI. First step, you need to complete the relevant driver installation according to the operation manual. Then connect the bias controller to the computer through a USB adapter board. Turn on the bias controller. Run the GUI software. Select the correct COM port and click Connect to enter operation interface. Enter measured heater resistance values in the text box and click the Set Heater Value button. For example, here we set the heater resistance value to 100 ohms. You can click the Red Heater Value button to check the current heater resistance stored in controller. Besides this, there are many other useful functions in the GUI. Fourthly, let me show you how to build a modulator system. The system includes the following components: laser, Mach Zehnder thermo-optical intensity modulator, 1:99 coupler, TFLN-NULL bias controller, signal generator, power adapter, optical power meter, ground wire. You need to wear anti-static wristbands before connecting the components. In the first step, you need to connect the laser's output to modulator's optical input port. In the second step, you need to connect the modulator's optical output port to the input port of the coupler. In the third step, you need to connect the 1% port of the coupler to the photodiode of the bias controller and connect the 99% port to the optical power meter. In the fourth step, connect the signal source to modulator with proper RF cable. In the fifth step, connect the modulator's DC bias port to the controller's bias output port. In the sixth step, connect controller to the power adapter and connect controller's earth pin to the ground. After the connection, now you can set up the parameters of signal source. In this case, we will apply a sine wave with a 1 MHz frequency, 0.5 volts VPP amplitude. After turning on laser and output RF signal, you can turn on the controller by pressing the power switch. You can see that the LED starts flashing. When LED is constantly green, the controller starts tracking working points. The parameters of the optical power meter gradually converge to a certain value. Fifthly, let me show you how to reset controller and switch point mode. You can reset the controller by inserting a jumper between our ST pin and GND pin and hold it for 1 second before disconnecting. You can see that the LED starts flashing, indicating a successful reset. The bias controller has multiple working point modes. The controller is working at null point tracking mode in default. If you want to switch to peak point mode, you can turn off the bias controller, insert a jumper between the PLR pin and the 3.3 pin, and turn on the controller. Thank you for watching.